Thank you for attending today. I'm Andres Marchante. I work for Dell Technologies. I work for the networking lab. And today I'm here trying to introduce you, probably you are aware or not, how the large language models are introducing in the networking operations and what are the relevance of this in this kind of technology. Well, the first step is talking about the motivation and a brief summary about why this kind of projects and why we are here talking about this. First of all, please, this is a brief summary. Don't get shy. Don't be embarrassed to answer this. I prefer to see right hands. Who of you use CLIs, SMP, Flow, NetFlow for managing or monitoring the network? Please raise hands. Me too. Okay, all of us. We are networkers, right? Who of you use network orchestrators, are used to manage networking elements with this kind of tools? Maybe. It's very usual today, okay? And who of you are embracing NetDevOps strategies? Let's say Ansible, Telegraph, or whatever. Well, a few, okay? Let's try to figure out what is happening in the sector. Do you think that this is the future of network operations? Let's see the complete picture. We are starting to develop networking with a huge amount of nodes. Maybe AI is the excuse, but it's fine. We are entering in a new networking era with very large networking inside the data center, right? The complexity of the topologies have started to grow. We are seeing new kind of topologies, not only closed networking. Also, we can see something like Dragonfly and other topologies that can be very complex, right? New standards start to evolve. The Ultra Ethernet Consortium is here, and the definition of the new standards are here. So Ethernet is starting to evolve more than ever, okay? Trying to cope business from other networking technologies, not only fiber channel just in the past, also now trying to displace InfiniBand, right? So what do you think about what will be the next decade standard to manage the network? Do you think that will be something like Cisco CLI-like, Junos-like, for those that they like it, JSON files? Do you think that this is the way we will manage the network in the next future? Probably not. We think, this is a vision, that the human language will be the way to manage the networking and the network fabrics in the next decade. Why? We need to try to simplify how to define the intent in how the networking will work, and then let something behind the curtain to manage the rules to create the network configuration to do this, just like the network orchestrators does using a GUI. But is so powerful, the GUI? For some kind of operation, maybe, but for others, we need agility, right? And nothing more agile than the network language, the human language approach to manage the network language, okay? We need to know how the network protocols work, of course. We need to know how the topology works, of course. But do we need the real details in how to implement all the detailed configuration to implement those intents? Probably not, because the CLI or all the networking interfaces to configure the network will evolve very fast, okay? So why this project? Well, addressing the complexity in the modern networks is very clear. We have very complex configurations. If we had to configure AI, for instance, features, we can spend a lot of time identifying all the parameters, all the figures we had to introduce in the network. Why to do this? If we had the possibility to introduce network tools that are based on open source standards, why not? We have a lot of tools around Linux to manage the network, okay? At the end of the day, Sonic is based on Linux. Why not using that? We need to reduce the amount of time to do troubleshooting in the network. If you talk with the network operations responsibles in all enterprises, in all organizations, they will say, I cannot be anymore the usual crime suspicious in a network incident, because Most of the time, I'm not, probably the server is responding so slow, the application stack is not working properly, but all the blames are going to the networking side. We cannot be anymore the suspicious for everything. We need to remediate problems and identify their root cause as fast as we can. And we need to have proactive alerting and notification of any problem of the network. The network are complex. We need to identify the problems not when the problems are going up, even before the problem arises. Well, we can try to contribute to the sonic innovation introducing this kind of technology. What are the architecture insights we are trying to figure out in how define a model to manage the network using, for instance, something like GPT or any kind of conversational interface or natural language processors for interact with the networking side. The first thing we are trying to figure out is a block diagram that comprises a source of truth. For instance, netbox is an open source tool we can use for define how the network should be. We need something that drives the configuration from the source of truth to the network fabric. For instance, Ansible is a good option, but there are a lot. We need information from the network. We need information from the switching devices. We can have syslog information. We can get SNMP. We can get information running commands like chow or whatever. Even GNMI, a networking management interface that is fantastic. We have the tools for recovering that information from network fabrics. Okay, for instance, Telegraph allows you to recover a lot of information. Projects like OpenTelemetry gives you collectors to retrieve a lot of information from the network devices. And we have databases and dashboards that are based on open source tools like Grafana, Grafana Loki, and others that allows you to manage that information even visually. What is the idea? Monitoring and validating the sonic fabrics, identify any problem and troubleshoot them, and then take that information and showing, for instance, a Grafana dashboard. If we see this diagram, we have a layer based on the source of truth, netbox, the Ansible controller, and the sonic fabric that will allow you to create a fabric with these tools and orchestrate all the configuration we have defined in the intent based on netbox and push that configuration to the switching fabric. Then we will have a validation and monitoring tool based on a natural language processing. So you can query the system, hey, what is happening with BGP between two nodes? Something so, okay? And then, using all the information that is recovered from the source of truth and the fabric, we can try to identify if the intent defined in netbox and how the fabric is working is aligned or not. That's the idea. And finally, if something happens, let's say that our BGP definition between two nodes is not working properly, we can try to identify the root cause and remediate the problem. Let's say, for instance, I have modified accidentally the AES of the peer. What happened? The BGP session will shut down, and we had to identify what is the problem and modify the configuration to recover the BGP session, right? It's a very usual problem that can be identified automatically and remediate using Ansible. So we will use the large language model interfaces for mainly two things. Identify what is the state of the network in comparison with the source of truth, and then instruct an Ansible controller to say, hey, apply this playbook to remediate or to change something, okay? These are the components, that are oriented to do this. We have a data ingestion layer oriented to recover all the information from the sonic fabric using the protocols we have in our hand. And that information is stored in a database that could be, for instance, Prometheus, influxdb, or Grafana Loki, if you are aware about what is this, it's a log analyzer that's very powerful. And then that information also allows all the components related to the LLM Python models to modify or to analyze the information we have in those cells. After that, we need to storage that information. For instance, the telegraph input should be stored persistently in our database. And then the RAG, or Retrieve Augmented Generative AI, is able to manage that information to compare between the SARs if everything is aligned or not. Once we have that, we can instruct an agent to modify, for instance, the network state. Launch an Ansible playbook could be a good way to do that. But if we have another kind of interface, let's say GenAI or GenAI, we can do it in that way. No problem at all, okay? And finally, a user interface layer that could be based in Grafana, okay? Some behavioral examples about how to use these kind of tools. This is an example of a natural language query. Validate if BGP is working correctly across the entire fabric, not one single node. We can query that information for, let's say, thousands of switches, okay? This will launch playbooks to recover all the information from the source of truth, what is the intent of the network, and what is the real state of the network, and start to compare automatically what is happening. Who will do that? An LLM. For instance, I have been playing with Mistral. Mistral is a large language model that could be run on top of ollama, for instance, but you can use Llama 322, whatever, okay? Any kind of LLM that could be used on top of an API server. The good part of this is today we are using general models, not specifically trained for networking. This is something I will talk in the call of action. But it's important to use an LLM model that is able to manage very good JSON structures or metadata, for instance, from SLM, XML, or any kind of a structured language, okay? Once LLM evaluate what is the situation, can use a method to remediate the problem if it exists or not. Let's say, if the BGP session is not working properly, locate what is the portion of code to launch and remediate the problem. For instance, a playbook to modify something in the BGP configuration. For instance, this is a snippet of code for doing this. We can see here how is recovered information from netbox, how the information is retrieved also from the fabric, and then validate if the information from both sources is aligned or not. Okay? Once we have the information from the system, something like this is the Ansible output that comes from the switches using, for instance, the Ansible for community sonic roles or collections, sorry. Once we have that information, we can compare with the information that have been retrieved from networks. Okay, we can see here that in the switches we have a BGP session established between the AES ending in 01 to another node ending in 02. Okay, and in netbox we have exactly the same definition. So the LLM response will be something like, okay, BGP is working properly, nothing to do. Okay? What happened if anything is wrong? Let's say that the BGP session is not aligned with the source of truth. Just in this case, we will collect the information from the switches and we will see, for instance, an event that says the BGP has been shut down. Okay? That triggers automatically the LLM to analyze what is happening. And then we will have recovering information from the source of truth. We will see the previous configuration. We should have a session between the AES 65001 with the AES 65002, but the fabric is not in that state. What to do? Well, automatically, the LLM component will say, this is a problem, we should fix this problem. We can say, well, we can instruct to the network operator to do something, only shows a warning and say, hey, guy, we have here a problem, do whatever you have to do. This is the root cause I have found, but in your app. On the other hand, we can even let the LLM to automatically remediate the situation. Okay, if we are so confident in the code we have tested and trained, we are able to let the code to automatically remediate the fabric situation. Just in this case, we'll launch an Ansible playbook to modify the AS that is wrongly typed in the configuration. Okay? So automatically, the LLM is able to identify a root cause and automatically launch a playbook to reconfigure the network and align with the source of truth. Okay? What is the benefit, or what are the benefits of using this? We will reduce the amount of time to identify problems in the network. We will reduce the amount of time identifying a problem and then correcting them. And another very important thing, what happens if we have a very large network with a lot of technology, not only Sonic, maybe other operating systems running in the network, and we need to agnostically create queries or create instructions for the networking side. We don't need to know nothing about the low-level configuration of any device. We can, let's say, we have a Sonic from the community, we have Sonic from Dell, from other vendors, and all of them have even their own CLI, not only the JSON-based configuration files for Sonic, okay? Just in this case, we can take benefit of all the interfaces that all operating system give to the system to modify the configuration. And we don't need to know nothing about the detail of how to configure that. Okay, that's the idea. What are the call to action about this? Well, what is the idea? We need to enhance interfaces for integrating the information with LLM. The better information, the more structured information, the networking monitoring interfaces the system gives to the LLM, better the results we will obtain from an LLM, okay? Because the prompting for that will be more accurate and more stable in the answers. And another important thing, we need to train models specifically for managing networking. Today, the models are general, okay? Or unless the models I have been using for this kind of purpose. But if we train a model from the scratch with exactly all the information regarding to networking interfaces that all operating system gives to assist to monitoring and managing models, we can identify better the situation and we can instruct better in how to respond to any event from the networking side, okay? So at this moment, we are trying to explore the possibility to retrain some models from scratch, introducing a lot of information about network incidents, all the information regarding to APIs, to CLIs, and of a lot of operating systems, trying to enhance the response that these kind of systems will have. That's all, folks. Thank you.
Any questions, comments?
I had a quick question about whether or not you're using function calling and some of the issues that you might have run into there. There was one slide where you were, the BGP example, like how does it know which function to call when you go from that?
You mean for obtaining information about the BGP session?
Yeah, or rather the steps in between the natural language input to knowing which function to select and call.
You can use, this is a brief presentation. I can share some snippets about how to do it. You have two approaches, okay? The first one is using, for instance, a bear model to extract terms from the query and then identify a set of possibilities. What are the information you are trying to gather from the network, okay? Let's say a catalog of possible actions you can do to recover information from the network. Another way to do it, more advanced, more sophisticated, let the LLM to identify, to understand what is the question and decide with all the catalog of the possibilities you have in the system, if you have a good trained model, for identify what is or what are the possibilities to retrieve information. For instance, I have tested a very, very short model, let's say 7 billion parameters, something so, about giving a lot of network incidents, and then let them identify what are the usual commands the network operator launches for identifying the problem. Then, when I query the system, let's say, I have a problem regarding to LACP, automatically identifies all the incidents related to that, and then pursues what are the common network operator commands launched to identify the problem and so on. But this is approximation that you need GPUs to train a model. Okay, I have the luck to be in a company that has a lot of GPUs to test. Okay, but if not, the better approach and a catalog of several possible, let's say, a tree of situations you can manage is affordable in using CPUs to use the model.
Okay, thanks.
Anyway, if you want some kind of insights, I can share. Okay. Very important. Sorry. Everything I have shown here is using open source. Nothing private. Nothing. No patent involved here.
Awesome. Any other?
So other vendors have put a lot of effort into writing documentation to train the LLM on. Is anyone looking at doing this for Sonic?
That's the problem. That's not the part of the calculation. We are trying to do it, but at this moment we are very small to do this because, to be honest, if someone told me 1 year ago you will be here talking about code, I will say you are crazy. I'm a network engineer. Today, 90% of my time is reviewing code and how to improve this kind of situations.
Hi. I just wanted to know, like in the call-outs, you mentioned that to train, we should focus on training the LLM models, right? But with the existing technology, or you have, in some years, we will have some upcoming new technologies, which will let us go to a situation where we will have some new problems to face. Any ideas how we could solve this kind of issues?
In artificial intelligence, we can do two things. First of all, let's try a model. You need to spend time to every time something is new to retrain the model. Is it affordable or not? Depends on how many GPUs you have. But the second approach is using embeddings. A RAG usually catches portion of information and tries to map to the model, to the current model with no retrain. Let's say that tomorrow we have a new release of Sonic, we have a lot of new, very powerful commands, and we need to integrate that information inside the current model. We can try to extract that information from the documentation you have and integrate with the current model using embeddings. It works, okay? But it's important to have the proper libraries to extract the terms and train how to extract the terms to integrate that information in the current model. But this is possible. Okay. I have played with that, but at this moment, the best result I have is using a retrained model at this moment, or a fine-tuned model, okay? But probably in the next decade, the embedding tool will be better. Okay.
Thank you.
You're welcome.